Hey folks, my name is Ricardo Gutierrez, and I would like to welcome you to the How to Connect to AWS in a Quick and Inexpensive Way Part 1. Today we're going to compare the connection types using Palo Alto firewalls and VPN connections. So why would you want to connect your data center to AWS? Well, one of the main reasons would be to connect your internal apps in AWS from on-prem. The other would be you may have a large database in AWS that you would like to connect from on-prem. You could also be hosting file transfer servers in AWS and you need to transfer files between on-premises and AWS. And you may have a requirement to encrypt the traffic between your data center and AWS. You could also use this VPN connection as a temporary connection while your direct connect gateway and your direct connect are being built, or you can use this as a secondary backup connection. You can also use this as a SD-WAN entry point, and the two connections or the two options we're going to see today is side-to-side IPSec VPN to transit gateway and the side-to-side IPSec VPN using GRE tunnels to the transit gateway. I'm going to go over the key differences between the side-to-side IPSec VPN to transit gateway and the side-to-side IPSec VPN using GRE tunnels to the transit gateway. So one of the key differences is that the IPSec tunnel that you build between your on-premises firewall is going to be 1.25 gigabits. So the bandwidth, the throughput between your on-prem firewalls and the transit gateway IPSec tunnel is going to be 1.25 gigabits. When you build an IPSec tunnel to the transit gateway builds two IPSec tunnels, so you will have 2 times 1.25 gigabits of throughput to the transit gateway. The side-to-side IPSec VPN using GRE tunnels to the transit gateway, this provides up to 5.6 gigabits per IPSec tunnel if you use a Palo Alto firewall as a virtual instance in AWS. So if you use maybe a Cloud Blade from Palo Alto, use as an SD-WAN appliance, it'll provide more throughput, or maybe a Cisco CSR, it'll provide more throughput because the firewall or the appliance would not have to inspect any threats. All that inspection will be done by your on-prem firewalls. The other difference is the IPSec from on-prem terminates to the transit gateway. The IPSec tunnel from on-prem terminates on the MVA. The MVA can be, like I said, a Palo Alto firewall, a Cisco CSR, a Cloud Blade SD-WAN appliance from Palo Alto. The other key difference is the lower cost and simpler architecture for the side-to-side IPSec compared to the side-to-side IPSec VPN using GRE tunnels. For the side-to-side IPSec VPN using GRE tunnels, you need at least one MVA running, like I said, Cloud Blade, PA Firewall, Cisco CSRs. This is a quicker setup. The side-to-side IPSec VPN using GRE tunnels is a bit more expensive, it's higher cost, but offers you much better throughput. It's a bit more complex because there are more components in the middle between the transit gateway and your on-prem, but it's going to provide you with more throughput. The similarities, both encrypt traffic between on-prem and AWS, so that's good. And both use IPSec to connect to AWS. Now what I'm going to go over is I'm going to go over the infrastructure comparison between site-to-site IPSec VPN tunnels and the site-to-site VPN tunnel to the transit gateway. I will mention all the components that are needed. So for the site-to-site IPSec VPN using GRE tunnels to the transit gateway, you need an on-prem router or firewall. You need one or more 10 gigabit internet connections. You need to build an internet gateway in AWS. You need an MVA, this could be a firewall, a router, and a SD1 virtual appliance. You need to run BGP on the MVA, very important. This solution provides dynamic routing from the transit gateway to on-prem. You will need an IPSec tunnels from the MVA to on-prem. You will need to build a GRE tunnel from the MVA to the transit gateway. In this diagram, I have a GRE tunnel built from the Palo Alto virtual firewall to the transit gateway. The GRE tunnel provides up to 20 gigabits of throughput. And this is actually the transit gateway connection attachment. You will need a transit gateway. You will need a BGP ASN on the transit gateway. You will need to enable ECMP on the transit gateway. You will need a CIDR on the transit gateway. This is in order for the virtual appliance to build a GRE tunnel to the transit gateway via a specific IP address. You will need transit gateway route tables, and you will need the transit gateway connect attachment. This connect attachment is the one that builds the BGP peer connection to the MVA. Like I said, a firewall, a Cisco router, or a SD1 appliance. And you also need a TGP peer. That's where you assign the IP address of the BGP peer that the MVA will talk to. Now, the site-to-site IPSec VPN to transit gateway needs an on-prem router firewall, an internet gateway. It'll provide up to 1.25 gigabits of throughput per IPSec tunnel. You need an AWS customer gateway. The AWS customer gateway is the IP address of your on-prem public IP that will be used to build the IPSec VPN tunnel. You will need an AWS site-to-site VPN profile. You will need a transit gateway as well. You will need a BGP ASN. You will need to enable ECMP on the transit gateway. You will need transit gateway route tables. You will need to attach the VPN connection. So these two options can coexist, but I would, of course, encourage you to just use one option. So I'm comparing these two options just so you can evaluate which option you want to use. So if you want a very quick connection to AWS, then go to the site-to-site IPSec VPN option, because you don't need an MVA in AWS. You just build the IPSec tunnel between the firewall, the on-prem firewall, to the transit gateway, and that's it. But the drawback is you will have 1.25 gigabits per IPSec tunnel. Whereas if you want to be a little more patient and build the infrastructure to have better throughput between AWS and on-prem, then you will want to go with the site-to-site IPSec VPN using GRE tunnels. This will provide you with up to 20 gigabits for the GRE tunnel. The Palo Alto firewalls, the VM700, can provide up to 5.6 gigabits of throughput. So I mean, that may not be the best idea, but if that's all you got, well, the only license you have, then go with that option. But would look for other MVAs like a Cisco router that can provide higher throughput. Well, thank you very much for watching, and look in the description below so you can get a chance to see the discounts and other free content. And please join the club. And if you need custom training, look in the description below. There will be a URL that will send you to a form that you can fill out and request your training. Some of it might be free, some of it might be paid, but feel free to fill out the form. And please like and share and subscribe and join the club. Thank you and have a good day.